Hi, and welcome to this VNS3 product demonstration. So let's start off with a quick overview of what VNS3 is. VNS3 is an overlaying software-defined networking product, which gives control back to the user of IP addressing, protocols, network topology, and security. It separates network identity from location. It's configurable in a mesh for high availability. You can create overlay networks across multiple clouds for geographic distribution and for cloud federation. And of course, it comes with a standard API and a graphical user interface. So there are 6 main functions inside of VNS3. These are a router, a switch, a firewall, an IPsec SSL VPN concentrator, a protocol redistributor, and of course, it's a dynamic encryptable software-defined networking device with an API in its own right. All of these 6 functions come together to create a hybrid virtual device, which is able to extend to multiple sites. VNS3 allows control, mobility, and agility by separating location from identity. And again, it gives back to the user control over encryption, IP addressing, and network topology. So we're going to look today at the following example, which is a federated cloud topology using VNS3. So it creates one flat network across multiple clouds. So let's have a quick look at that topology first of all and see what it looks like. So what we've done is we've created several VNS3 managers, 3 in total, and we've put them in individual clouds. The first 2 managers are inside of Amazon Web Services. We've placed manager 1 inside of AWS EC2 in the US East region. The second manager has been placed inside a VPC inside of AWS EU. This is manager 2. And of course, for all intents and purposes, each region within Amazon is an individual separated cloud. Then the third manager has been placed inside of IBM Smart Cloud in the Einigen, Germany data center. These 3 managers have been linked together to create one global overlay network, which is an overlay subnet of 172.30.0.0/22 network. The 3 managers have been paired together, and these are much like a network peer in networking terms, and they share each other's topology, and they can talk to each other, and they can talk to each of these individual cloud servers, no matter which cloud server is connected to which manager. They can mesh across and talk to each other from each respective VNS3 manager. So VNS3 manager 1 has a public IP of the following, and it has its own individual overlay IP as well. And manager 2 has its own public IP and individual overlay IP, and manager 3 has its own public IP and overlay IP as well. Manager 1 has an active IPsec tunnel to the Chicago remote office in this example, which has a couple of workstations in it, and has a different remote subnet of 192.168.3.0/24. It has a backup tunnel, which is connected to the second VNS3 manager in topology. This is for backup purposes. So this tunnel remains down unless this tunnel comes down, and this tunnel then comes up and replaces the connectivity and allows connectivity from the Chicago remote office into the federated overlay network. The same for this passive tunnel as well, this spillover tunnel coming from VNS3 manager 2 into the Chicago data center, and it has an active tunnel which goes to VNS3 manager 3. The customer data center in London has 2 servers in this example, and has a different subnet again of 192.168.4.0/24. So you can see in this whole topology we've got 3 different subnets, and we're linking them all together. So I think this covers everything in this diagram. Let's go ahead and look at each individual manager and what they look like. So first of all, manager 1, I've created this manager in the US East region. I've used our standard AMI, and I put it in a security group that has the correct privileges to allow me to access this manager through the GUI and through all of the necessary ports to connect to IPsec and to the other managers, for example. Okay, so this is the manager. You can see it is at 184, the IP address of manager 1 down here. Okay, so it has several links. You can see that it's linked to manager 3 and to manager 2, and these are the remote IPs, the manager, the internet addressable public IPs. These are up and running and reachable. You can see it has a collection of several clients. These are the clients that you can see here: client A, client B, client C, client D, client E, and client F. Notice that the client C are inside, client C and D are inside of a VPC on an isolated VLAN. And you can see over here, the physical IPs are private isolated VLANs. So this is client server C and client server D. And client server E and client server F are connected to manager 3, as you can see here. Boom, boom. And you can see that they're connected over to manager 3 in the topology. Again, this is manager 1, so we'll look again. We'll look at manager 2 and manager 3, and you can see the similar topology because all of the topology is shared across peered managers. You can see that this manager has a remote endpoint VPN tunnel defined to the Chicago remote office, as per this diagram here. This connection, and that is connecting up. You can see the local subnet of this manager. This is the global overlay network 172, and this is the remote subnet of the Chicago remote office, which is the 192.168.3.0 subnet. You can see that there are other remote subnets connected as well. In fact, there are two. This is the Chicago remote office, which is connected directly via IPsec, and you can see that here. And then you can see the London data center, which is a 192.168.4 network, and that's depicted here, and it's connected to the VNS Cube Manager 3. And again, it's attached to Manager 3. So that's Manager 1. You can see that it has been set up by Manager 1 by defining its role as Manager 1 here. And you've got the standard features which you can add inside of any VNS Cube topology to add individual firewall rules, other routes, make backups, all of that. But we'll not concentrate on those today. We'll talk a little bit more about the federated cloud topology that we've created. So you can see here I've got 6 clients connected. These 6 clients are based across 3 different clouds. So cloud server A, cloud server B is in EC2 East, and cloud server C and server D is in in VPC EU, and the E and F servers are based in an IBM SE data center. So what I'm going to do is I'm going to ping from the cloud server A to cloud server F on the private overlay network on that server and show you that works. So let's go to cloud server A, and I will verify that this is cloud server A by showing you the IP address of the overlay network. Okay, so you can see that the overlay IP address has been configured using the VNS Cube client pack that's been installed on this client server. And it's got an overlay IP address of 172.31.1.1. Of course, it's still got its public-facing IPs as well, which are hosted in the Amazon EC2 East region. So I'm going to go ahead and ping cloud server F, which is over in IBM, in the same IP subnet as this. 172.31.1. I believe it's 21. Yes, .21. And you can see that that server is reachable through the same IP subnet, even though this server exists in a completely different part of the world and a completely different cloud. We have grouped all of these servers together in one global overlay subnet. Okay, so what we need to do now is have a quick look at the second manager. The second manager has been hosted in a VPC inside of EC2, sorry, inside of AWS in Ireland. You can see here's the VPC ID. Here's the IP address that's been assigned to it, and this is the AMI that I've used to create the manager. Let's have a look at that directly. Again, verifying the IP address matches the topology here. You can see the same sort of stuff. It's connected to other managers, manager 3 and manager 1. All of the client servers that are available as well. And this time, because we're directly on manager 2, I can detach some of the client servers if I wanted to. Similarly, if I was on client 1, I could detach the client servers that are attached to manager 1. And I can see the 2 backup tunnels on this manager defined. Let's have a look. You can see them here, and you'll notice that in this manager, both of those tunnels are down and not connected because they're failover tunnels, and they will only come up at the point when the primary tunnels have gone down. It's important to note in this diagram that the failover here is driven by the remote IPsec devices. So these IPsec devices need to be capable of that failover for this feature to work. And these are the remote subnets. Again, we've got 2 remote subnets. This is the Chicago remote office, and this is the London data center. Okay, and I can just verify that this is manager 3 by showing you manager 2 by showing you manager 2 in the manager peering setup. Let's have a quick look now at manager 3, and it has been given a public IP of 129, and it's in the IBM data center. So here's my IBM Smart Cloud Enterprise interface, and I can see here in the Anakin data center, I have my third manager, and here's the IP address assigned to it. So let's go ahead and look at that. So this is manager 3, 192. And you can see it's got connection to manager 2 and manager 1. These are the other managers in the overlay topology that I've created. And you can see that I can admin the connections to manager 3 as well, because these servers have been connected to manager 3. It's important to note that, of course, if manager 3 does go and leaves the topology by failing for some reason, the connected cloud service will automatically fail over to the next manager in the topology, which would be manager 2. And if that one was to go, these cloud servers would fail over to manager 1. So this is a highly available infrastructure. You can see that this manager has a connection to the London data center, which is connected. But it can also reach the Chicago remote office because it's got a remote subnet defined on it as well. So even though this manager 3 has this active IPsec tunnel here, it still knows about this tunnel over here and still knows about this remote subnet. So these devices effectively are able to reach all the way up through this overlay subnet and back down here, and vice versa. And of course, you can use the standard features inside of VNS3, such as firewalling, adding other routes, and adding in BGP and further VPN connections into the topology. So that concludes today's demo.